This is a one-of-a-kind building. There's no other building like this in the world.
It's a structure that has been designed to give the University of Maine the ability to test mammoth wind turbine components that might someday harvest as much as 5 gigawatts of electricity from the Gulf of Maine. Onto this test stand, turbine blades made of new composites and measuring hundreds of feet in length can be bolted and tested for strength and efficiency. It's all part of the new offshore wind laboratory at the university's Orono campus.
The biggest blade that they're going to bolt to that is 70 meters, which is roughly 240 feet long. They'll flex it, they'll bend it, and they may bring it to fatigue. And the blade tip pit behind me is 32 feet by 96 feet long, and it's designed for the width of the blade. The blade is so big that the width wouldn't fit inside the building, so it allows it to go down in below the ground level and gives them a working space.
A Cianbro team served as the construction managers on this project, which broke ground in May of 2009. Cianbro subcontractors installed concrete and steel to withstand incredible forces, similar to what the marine environment can throw at a floating wind farm 50 miles offshore.
That faceplate is 15 by 15 feet square. It's got 2 plates on it. One on the outside you're seeing is 2 inches thick. There's one on the inside, which that's a 6-foot thick concrete wall. That's also 2 inches thick, and the series of holes are for through bolts. They'll bolt through and then anchor on the other side with nuts and washers to hold up the blades. That's the actual test stand. That's what the blades will be bolted to, that faceplate that you see. And what they do is they'll bolt those blades, and then they'll set up the actuator frames, attach them to them. They'll either videotape or they'll put sensors on them, so they flex them. They may flex them 1,000,000 times and then bring them to fatigue, and that's primarily just for holding the wind turbine blades. The test stand is designed to take 50 million foot-pounds of horizontal torque, so when they're bending these blades side to side, that thing's not going to move. The reaction floor, which is a sleeved, empty sleeve, which you can put a threaded rod down through, will take a actuator force of 1 million pounds of force. So these things are set up for a lot of sideways torque and a lot of uplift.
There is also some versatility built into this facility. The blade tip pit that allows extra room for giant blades to fit into the lab also doubles as a miniature ocean, 12 feet deep, for modeling the impact of wind and waves on floating turbines.
They're planning on using it as a wave pool and a wind pool. They'd build scale models of an offshore turbine sitting on a platform, floating inside of the blade tip pit, and they'll introduce it to wind and waves and see how it reacts. The primary design was for offshore wind testing. The facility can actually do much more testing than that. They've got an environmental chamber, which is roughly 30 feet by 30 feet by 25 feet tall. They could put a car in there if they wanted to, and what it does, it simulates temperatures -60 to +140. It'll simulate ultraviolet light comparable to the sun, and they can put a fog mist in there, or rain, and there's much more they can do in this facility than just testing offshore wind.
Apart from the scientific benefits of this project, there are economic and environmental pluses also. First, there were the local construction jobs, and then there are more jobs that could come about if and when the university invents components for production. Also, in keeping with the project's environmental focus, the facility achieved LEED Gold certification in 2012.
Everybody's been good to work with. It's been a great job. We look forward to working with the university again.
With the project nearing completion, Cianbro CEO Pete Vigue joined Professor Habib Dogger, the founding director of the university's Advanced Structures and Composites Center, for a luncheon with the construction crew. The celebration marked 58,000 work hours without a recordable injury. It was also an opportunity for the two leaders to talk about the future accomplishments that will take place here.
Because there are a lot of folks out there that think that, you know, we're good old state of Maine, the lobster's great, the hiking's great, and it's a great place to go on a vacation. And I'm here to tell you today that it's a great place to work as well, and bring up a family and grow a business. And so I'm asking you, don't believe anybody when they tell you that we're at the end of the road and we don't have the capacity to take this state to a whole new level.